Hello friends, welcome to your only channel Times of Coding. Today in our series Scala Express, we will learn how to use partial function. Partial function session will help us to define methods and leave redundant code aside while programming. In previous session we have learned functions, local functions and first class functions. In this session we will focus on how we can make functions more shortened or concise, function placeholders, and how to use partially applied functions. So here I am showing one of the example which we have discussed in my previous session. In this filter function, what we have done is we have defined list and we have named as numbers. Because this number is a list type, that's why we can call filter function, and then we are defining one function inside the filter x colon int. Int is the type, the value which we will pass as argument in filter function, and then we are placing one expression to check the condition. In order to recall what is filter and how to use filter function, you can go to my previous video. So in above example, if you see, Scala will immediately knowing after the dot filter function that you are passing the int type. And how it will know? Because we are having numerical expression. So when we do numerical expression, our passing value will be the int type, and that by default Scala will understand. So in order to shorten our function, we can define our function without having the colon int, because the type is obvious for Scala. So we can shorten our function and we can write like this, where we can simply skip the colon int. It is just not about the colon and int type, because compiler know. In fact, now because we are not having any column or type identification definition with this function, we in fact can remove the braces as well. So here I have just removed the braces. Now if you see, if we have removed the braces, then what is the use of x is equal to right arrow to x? Because here inside the filter function, if you define the same statement with placeholder also, it will work the very similar way. So we don't need to even keep the x is equal to greater than x. So for that we will define a placeholder literal here. Underscore we call as placeholder. In Scala, underscore means placeholder. So we can consider this underscore to fill in the blanks. Now if you see this example, I'm sure you must be having few doubt. So let me explain now. You need to treat this literal value as a fill in the blanks type. So when we define like this, numbers dot filter placeholder less than is equal to 4, that means we are actually telling this filter function whatever information come inside, you just need to do the expression check whether it is true or false, and on basis of true and false you need to filter out some value. And it is totally optional to use the placeholder. In fact, this statement and this statement is totally equivalent to each other. But yes, if you need to shorten further, you can define like this as well. Placeholder is a very good and powerful way to work with the Scala language, but we need to understand its limitations as well. If you make use of this placeholder more freely in your statements, you may end up having compile time too many parameters you're defining, or you might be missing some parameters. We will see how. Going forward, I'm defining one variable here called sum, and inside the sum I'm keeping two placeholder. In previous example, we have seen how to work placeholder inside the filter call as an argument. Now we will see how to define a function logic with the placeholder. So here if you see, our compiler itself is getting confused. What are these two arguments I'm going to get? So when we are defining more than one placeholder, especially while defining the logic, we need to write with the type. So how we will write with the type? Here is an example. So whenever you are making use of placeholder type definition, we need to define with its type. So here I'm defining one function called sum, and here I'm taking two placeholder arguments. First will be int type and next also will be int type. When you execute this, Scala will define this function which will have two parameters, int type, and while calling this function you will pass these two arguments 2 and 5 inside the sum, and it will get us the addition outcome which is 7. We have defined this sum function with two placeholder literal because we were sure that we are going to get at least two values in order to do the sum, and these value is not going to reoccur again and again. So it is just one time occurrence, and that's to two values in one shot. That's why we have defined like this. So far we have seen how to use placeholder inside the function body. Now we will see how to use placeholder literal with function call. So I have given one example here where we are calling for each function on numbers. This numbers is the list which we have defined in earlier examples, and then we are doing for each to iterate through all the elements of this list, and then we are keeping println space placeholder. So that means this statement will simply iterate through all the lists and it will print as a debug messages all the list elements. One thing to notice here that we have given one space between the println and the placeholder. If we don't keep this space, then Scala will get confused and it will look for println underscore function in its library. So we should always keep one space if we want it to use as placeholder call with function name. Now few of you might have confusion, then why are we defining or what exactly happening inside? So I'll give you the exact what Scala will be converting for us as a placeholder form. Now we are defining numbers.forEach in this example if you see, and then we are defining inside the braces x is equal to greater than println, and with this println we are passing one argument as x. So that means we are doing the iteration on the number list and then we are printing out all the elements of this number list in each line as debug message. So when we define our statement like this, Scala compiler actually converted in this manner and then it executed. So it was for our advantage purpose because we wanted to shorten the functions. So now we have seen how to use placeholder and how compiler behave with placeholder when it execute the program. Now I think it's a fair time to understand partially applied functions also, and this placeholder is having very meaningful role to play while defining partially applied functions, which we will experience now. So here I'm defining one function addition and it is having three parameters called x, y and z, and then we are making addition of it, and the return type we will get out of this function is int type. Now this is the most general form of defining a function which we have seen so far in my all the previous videos as well. Now in order to make this addition function as partially applied function, we need to write one variable called sum, and then sum is equal to addition space placeholder. Now most of you may be thinking that why are we adding another wrapper to addition function? Because if I can call addition function with three parameters, that means it will get us the result. So anyway we can work it out in this way. So why are we looking another form to define some partially applied function? Now I'll tell you the advantage. So let's say you went into supermarket and you wanted to cook some vegetable dish today, which is called kadhai paneer. So as an ingredients of kadhai paneer, you first need the paneer, then you need some masalas, and then you need the vessel called kadhai. So let's say you went into a supermarket and then you bought a paneer, you bought the masalas, and now when you were looking for kadhai, you didn't find it. Now in this case, you have got two options. Either you can exit from that store, or else you can bought the items whatever is available in that store. So since it is a corona time, if you visit next store also, there is no surety whether all three items you will get at one place. So our best educated advice would be you first pick whatever is available and then look out for another option in another store. Now only pending thing is the kadhai. So you made a visit to second store and there you got the vessel kadhai. So your requirement is complete. This is very practical life example I'm throwing to you. In fact, your requirement was very clear what you wanted to achieve and you were having a plan also, but because of due to unavailability few ingredients or vessel in our case, we could not achieve at once. We have got the partially applied functions. Now we will go to the above statement called addition space placeholder. Now I will tell you what exactly happens when you write your statement like now. The Scala compiler will generate a class for you, and inside this class you will by default get a method called apply. And since here we have defined placeholder to all the arguments which we were expecting in this addition, so compiler created apply method will have three parameters x, y and z same way. And that class method you can call on sum because sum is the reference variable which is actually referring to addition function. So with the help of sum.apply you can call that automatically created function. Now moving on, I will demonstrate in one of my example also. So if you see here the above defined function, we have defined just sum, and inside the sum we have given the addition space placeholder value, and we were still able to call this. And since we have defined this addition space placeholder, we in fact got an option to call this function as apply. But in both the cases we need to pass all the three arguments. So far we have seen the automatically created class and its apply function, but we have not talked much about partial application. So now that we will see in my next example. Here I am defining val sum is equal to addition, and inside the addition I was passing two arguments as 10 and 20, and for third I am defining one placeholder with the time. So if you relate this example to our kadhai paneer example, you will get to know what is really happening. So here we are passing in fact two ingredients which we have got after doing a visit in first store. We are still pending with the third ingredients which will make a requirement complete and in order to produce some dish. So here, because we don't have the third argument yet, we are defining placeholder and then its type. So if you remember earlier, we have defined whole three parameters. So our apply function was having three parameter requirement. Now we are defining sum with addition function call, and inside that function we are keeping two arguments, but the third one we are keeping as placeholder. So here also Scala compiler will create one class automatically for us. Inside that class it will define one apply method, and this apply method will just have one parameter now because one parameter only has got placeholder. The next time you will call sum.apply, it just expect you to give one int value, not three. So if you give one int value, by default it is already having 10 and 20. So your logic will be perfectly fine, and if you execute you will get result of 60, which we expected. Now after defining like this, if you call this function with three parameters, you will unfortunately get too many arguments error. So that means we need to be a bit careful about using the placeholder while working with the Scala language. So now in fact you have seen how to use placeholder while defining the method and how to use placeholder while calling the function. The recommendation to use placeholder would be, if you are expecting a number of variable, you can use in fact with your function name as well. Otherwise, we should always skip usage of placeholder. So if you see in this example, I'm simply defining number, which is a list type, then for each, for iteration, and then println. This println job is to print all the numbers, whatever is throwing to this function. So here we are not defining any literal. In fact, we are not defining any placeholder also, and this is statement perfectly fine. And when we execute, it gives us this outcome. So far in theory, we have seen how to make functions even more shorter, how to use function placeholder, and how to use partially applied function. Now it's time to do some practical. First, we will come to IntelliJ window, and there inside the function package which we have created in our last session, we will create Scala worksheet today. Here we will define partial functions. The very first example which we have seen today is to define the number list and to iterate over through all the elements of that list. So here I'm keeping the same example. I have defined list here, and then we are doing filter operation, and inside that filter we have given the condition called x need to be less than is equal to 4. So expected value out of this would be 1, 2, 3 and 4. And then next we have seen how to even shorten this function. So I'll simply leave the redundant type, and now it is perfectly fine. Now I think this braces also is the redundant code for us since we don't define any type. So compiler in fact allow us to write in such a way. Then we talked about placeholder. So here I'll keep it 1 underscore, and compiler is fine and interpreter is also fine. So far we have seen how to use placeholder inside the function call. Now I will define a function with the help of placeholder. So here I'm keeping same example which we have discussed earlier today. Our sum function will have two parameters and it will add this parameter. We need to define like this. When we are defining some function with the help of placeholder, we need to keep it with type. So this is how we define and this is how we call. Now it's time to execute, and it gives us the expected value 7 because we have given 2 and 5. After this example, we have seen if in case we wanted to print, how we can use the placeholder. So now I will define one list, and here with this number list, I will define for each, and inside that for each, I will keep it println and then placeholder. In fact, in this manner, println can work with placeholder and it can get us all the value iterated from this list. After that, we have discussed now what exactly compiler will be doing for us in that case. It is actually replacing this placeholder with this type of a statement. Now we will execute this and it will get us the exact same output. Now after this example, we have defined one function called addition. Here I'm keeping the definition and function body. Addition takes three parameter x, y, z, return type int, and it does the addition. And this is how we call this addition function, passing argument as 10, 20 and 30. When we execute, we get the expected 60. Now we will see the partially applied mechanism with this addition function. So here I'm defining well sum is equal to addition with placeholder. So if you see, this statement get us the another function definition called sum. It may looks like another wrapper for addition function. Now when I call, now I can call this sum function as general way by giving 3 arguments in it. When I execute, I'll get 60. Now since we have defined this addition with placeholder, it is having apply function which is coming from the compiler created class definition function. So now this statement will also get us the exact same outcome which we expected. Now it's time to define this addition function with placeholder parameters. So I'm keeping 10 and 20, and 1 I'm keeping as placeholder. So now if we call with all the 3 arguments, we will see what happened. The Scala compiler gives us compile time exception. So I'll remove these 2 arguments from here and I'll do the run. So first it executed this statement called sum 30, output as 60, and this method still has the same problem because we have not resolved it. So now I'll just remove this method and we will use apply function. Okay, by using apply function also we will get the same outcome. So with this example we have covered partially applied function. Now the last thing which we have covered in today's topic is, should we really use placeholder with our function call? So that we will see in this example. Defining numbers.forEach, and inside that for each I'll keep println. Previously if you remember, we have given println to placeholder literal. Now I will simply remove this literal and I'll try to execute. Okay, so it is giving us the exact same outcome. With completion of this example, we have covered today's topic, how to shorten the function placeholders, partially applied functions. I hope you liked the video. You can subscribe my channel. To get new video notification, you can press the bell icon. Thank you. Have a good day.